All right, everyone. So it's been a while since we have done some translation problems. So again, we're in the beginning of transformation geometry. All right, I know we've been back to a few previous contents because of our quiz, but now we're going back to the future. We're going back to transformation geometry, which is just if you have the book and if you want to follow with the book, it's page 401, and we're doing translation, which is the first part of it, and what we covered in the last lesson that we were actually together at school. So let's recap by doing a problem, a very simple one, the simplest it gets. So find the image point when the point P to -1 is translated through 3, 4. Alright, so this is a vector, right? From this 3 here, you understand this is x and y, right? X and y. So this is how much we're going right or left. In this case, since it's positive, we're going to the right. And this vector here, it's 4, so it's up or down, but since it's positive, we're going up. So let's plot our point P. X equals 2 and y is -1. So our point P would be here. If we go 3 to the right and 4 up, we would end up here. So this would be our point P prime. We could calculate, if we plot this grid, we can check out the values, but we don't actually need that. Remember, we could write this as P to -1 is undergoing a transformation, and here we could write the vector 4, 3. And what's going to happen now is that P prime will have coordinates 2 plus 3, so we just add those numbers. So here would be 5, and -1 plus 4 would be 3. So that's why the coordinates are 5 and 3. As simple as that. So let's try another simple example. Alright, remember that you can always pause the video and try it for yourself before you move forward. So we have now a point 5, 2, and we're translating this through the vector 9, 1, 4. So first of all, let's do this one a bit differently. Let's do it mathematically, and then we can plot and check. Okay, so this is our point P, and and this is our translation vector, -1 and 4. So P prime would be 5 minus 1, 4, and 2 plus 4, 6. That would be where we would assume, right, our point to be. Now let's plot those points. So P is 5, 2. So our original point was here. That's P. And we are translating our point to P prime through -1 and 4. So -1, we're going backwards, right? Since this is -1, we're going backwards. So in this case, to the left, because it's negative. Alright? And this is positive, so we're going up. Even though we're going backwards, we're going up because this is positive. So we're going 1 backwards and 1, 2, 3, 4 up. This would be position of P prime. And if we check 4, 6, 4, and 6, there we go. Okay, so our problem could be something slightly different. It could give us 2 points. We could call them P and P prime, or anything that you would prefer. And we might be asked, what is the translation vector? Okay. Now this is actually quite simple, right? Because you just have to look for the difference. So from 3 to 3, you've changed 0, and from -2 to 1, you've actually went up by 3. If we plot the points, this is 3 and this is -2. This is our original point. And our next point is exactly the same x, but 1, 2, 3 units up. This is P prime. If you notice, that's 0, so it's either right or left, and 3 up. We could do that also by calculating x prime minus x, y prime minus y. Observe that when I do x prime, this is x prime and this is y prime, this is x, this is y. Okay, I'm just calling those names pxy and px prime y prime. So when I work that difference, that's 3 minus 3, and here that's 1 minus -2. So 1 minus -2. I'm just putting these brackets so you don't commit any mistakes. You notice that it's 1 minus -2, so it's going to be plus. It's going to turn into a positive. So this will be equal to 0 and positive 3, because -2 is going to be plus 2, so 1 plus 2 is 3. So we reach the same vector. Okay, so we can solve this just by, well, looking at it. You might find it. You might plot some kind of graph, so the vector going from P to P prime is exactly this vector. And you can also work out the difference and find the vector as well. You can pick the way to solve the problem. Now, sometimes we're going to be given some shape and we'll be told either the translation vector or the position of some point of that shape afterwards, and we might be asked to draw, to find coordinates of points, to find vector, and so on. So let's solve one of those problems. Remember that you can always pause the video and try to solve yourself and compare the answer. So we've got a triangle ABC, and the sides are -1, 3, 4, 1, and 0, -2. So the question asks us first to draw, then translate by a vector 4, -2, find coordinates of points, and what is the distance that each point has moved. Okay, so first of all, let's draw. So A is -1 and 3. So this is one point of, this is point A. Now point B is 4, so 4 forward and 1. This is our B. And point C is 0, so nothing left or right, and -2, so it would be here. Right, so this is our triangle. I'll try and draw as best as I can since I've got no ruler here. Alright, pretend that's a nice triangle. Okay, now translate by vector 4 and -2. So you're translating 4. So let's take point A first. 1, 2, 3, 4. And -2, so 2 down. So this would be the new position of A. So this is our A prime. Now C, 4 forward and 2 down. So this is our C prime, and B, 4 forward and 2 down. Again, remember that we didn't actually have to draw if the question didn't ask us to. We could just easily calculate any coordinate of those points just by calculating the vector, using the points and going through the vector. For example, A prime which I can call, let's call it x prime and y prime, just because it would be -1 plus 4 and 3 take away 2. So -1 plus 4, that would be 3, and 3 take away 2 is 1. So let's see, a prime should be 3 and 1. So you can see that it actually works. It does work. The only thing is that we were asked to draw. So coordinates of point A prime, B prime, and C prime. So B prime, we could just do that, but we have the points there. So B prime now is 8, and take away 1. If you notice, 4 plus 4 is 8, and 1 minus 2 is take away 1. And C prime, what are the coordinates? Oh, this is not a nice way to represent a point. Okay, so let's write the proper way. A prime, right, coordinates 3, 1. B prime, coordinates 8, and take away 1. And C prime, coordinates, now we could calculate, it would be 4 minus 4. But if we look here, it's also 4 minus 4. 4 minus 4. There we go. Now, through what distance has each point moved? Well, it's the length of that vector. And if you observe, we can calculate, because it's the hypotenuse of a right triangle. This height is the height that we have displaced. In this case, it's -2. The length of the side of this triangle would be 2, because length is always positive. The other length, the length of the other side would be 4. So this is 4. This is 2. If I want to find the hypotenuse, and I'll not call it x, just not to make this more confusing, let's call it A. Okay, so, or H. H is a better choice. Right, H. So H squared would be 2 squared plus 4 squared. That's our Pythagoras theorem. So H would be, let's calculate this first. So 4 squared plus 16 squared, that would be 20. So H is root of 20. We can simplify this, right, and get a third, 2 root of 5. So that would be the distance that each point has traveled when we have applied that vector. Alright, so let's say that we have an equation of a line, and we're told that this line has been translated through some vector. So this is just translation. And then we're asked, okay, what's the equation of the new line? So first let's draw this line. So there are several ways of drawing this line, and you could make a table, you could find the y-intercept and the gradient. So I will go with the intercept and the gradient, just because for this example it's simpler. But that does not mean that you couldn't follow another method, make a table x, y, choose different x's, different y's, and plot your line. However, you see that in this particular case, it's just simpler to follow this other way, because I do know from the equation straight away that my point of y-intercept is 1, so I know that it's going through here, and my gradient is a half, so that's rise over run. So I'm going twice as fast running than rising, so I'm going twice as fast on x than on y. So this would be another point of my function. This would also be another point. I can always walk 2 and 2, or 4 and 2, and right? And I can find more points on my equation of my line. And here it would also touch, here would also touch, and we can try and graph. Not as easy as it seems. We can try and draw, yeah, well, assume that's a line, okay? That's roughly a line. Yeah, not time for perfectionism here, but yeah. So, okay, so that's our line. Alright, it continues both sides. So it would continue here, it would continue there. I just don't want to make a fool of myself. Keeping trying to draw that. Now, I have translated 3 in -1. So there's a point here that I know, right? I know that point is part of my function. I call that point P. And what would be the coordinates of that point P? Well, x equals 0 and y equals 1. So those are the coordinates. So when I get that point through vector 3 and take away 1, I will get another point, which will now be 3 and 0. And that has to be a point in my no line, right? So this new point is a point of my line. But the gradient, since I've just translated this line, it should have the same gradient. So this point should also be there. This point should also be there. Rise over run, right? So my line would be something like that, right? If you're not very okay, that's fair enough. Now, how can I find the equation of this no line? This should be a point of my line here, right? So how can I find the equation of this no line? Well, I know that my new line should have the same gradient, but a different y-intercept, which I don't know which one it is. Since this point is part of my function, is part of my line, I should be able to replace x and y in my function and find c. So y, when y is 0, x is 3. So here I can find that c would be -3/2. Right? And then I can just write my new equation. It's the same gradient minus 3/2. That would be the equation of our translated line. Now let's try a different line and a different vector. So our new line is y equals 2x plus 3, and our vector is -1 and 2. So again, if we don't have to draw, if we're not asked to draw, don't. Unless it's going to make your life easier, unless you really have to do it, don't, because the gradient's going to be the same, and we just have to find a new point of that line. So for example, here in this equation, let's first solve it without drawing anything, and then we can draw. So y equals 2x plus 3. So this is my y-intercept, right? So this is my y-intercept. I know that point P, which, well, the y-intercept means x is 0 and y will be 3, is undergoing this translation. So 0 and 3 through -1 and 2. So my new point P prime will be -1 and 5. 3 plus 2. So I know that this point is in my new line. So my new line, which has the same gradient because I'm just translating things, will have a different y-intercept. And since this point is part of this line, I can just replace those values. So when y is 5, x is -1. So this is going to be -2 plus c. So here I see that c would be 5 plus 2, which is 7. So our new equation would be 2x take away 7. That's our new function. If we plot this line, so y equals 2x plus 3. First of all, 3 is a point here, that's our y-intercept, and our gradient is 2 now. So it's going to up. When we go on right, we go 2 up. So that's roughly our original line. Roughly, very roughly. And our new one is going to be translated by -1 and 2. So this point, we could draw this vector, right? It's -1, so it's 1 back and 2 up. So it's 1 back and 2 up. So we have translated that line through that vector. And what would be the new line? Well, it's same gradient and just different y-intercept. So our y-intercept is 7, which matches with our rough drawing here, right? So yeah, that might be perhaps the hardest kind of problem that you guys are gonna face regarding translation. And it's fairly simple if you look at it. It's just different numbers. You're either going to be asked to draw, you should be able to draw. It's much easier to draw in paper anyway, but if you're asked to do it, you should be able to. Okay?